Let's look at some questions regarding arithmetic progressions, some exam questions about arithmetic progressions only, okay? Because in most situations, you're most likely going to have a combination of arithmetic and geometric, but these ones are only about arithmetic progressions. The first of which is this one. This is from October-November 2008 paper 1. And it is question 3. The first term of an arithmetic progression is 6, so A equals 6. And the fifth term is 12, so U5 equals 12. The progression has n terms, and the sum of all the terms is 90, so Sn equals 90. Find the value of n. So I read the text, I already identified all the things that I needed to identify, and here they are. So in order for me to get n, I will also need to get the value of d, the common difference, but I have enough information to set up two equations, so I can have then simultaneous equations, right? So un is 12 when n equals 5. So I plug in and I substitute the correct values over here. This is going to be one of the equations, which will allow me to get directly the value of d, which I then can plug in on this equation over here for the sum of the first n terms, and I know that this is going to be 90, all right? And by solving this, I'm going to set up a quadratic. I solve for n. Eventually, at the end, I'm going to have a negative value of n. That doesn't make sense, so I'll keep the positive value, and that's going to be your final answer. And you have basically 4 free points. Now it's a winter 2012 paper 11, and it's the first question, also 4 points. Let's see. The first term of an arithmetic progression is 61, so A equals 61. The second term is 57, so U2 is 57. With these two, you can directly get the value of D. This minus that is going to be the value of D. The sum of the first n terms is n, so Sn equals n. You have to find the value of the positive integer n. All right, let's just write down what I just said. D is 57 minus 61, so the common difference is minus 4. You are subtracting 4 every time you go up in the progression, so you get smaller and smaller. You need to get the value of n. So substituting the values on this expression, you will get one expression in terms of n for un. That's not what you want. What you want is the value of n. But you also know this, that the sum of the first n terms is n itself. All right, so Sn equals n. You just put here the expression. All right, the n's are going to cut out. Okay, so it's just a matter of solving now, because you know, let me just check here one thing. Yes, it's actually simpler than what I did over here. You don't need this for anything, right? You can just use this formula over here, all right? Because you know the value of A, you know the value of D, okay? So it's just a matter of solving this equation, and it gives you the value of n as being 31.